These are CH-32 and CH-33 errors. These errors are caused by excessive discharge temperature of compressors 1 and 2, respectively, so their solutions are quite similar. The main reason for this raise in temperature to occur is lack of refrigerant or leakage. As the amount of refrigerant goes down, it will take more heat. Also, damage in the discharge temperature sensor or damage in the EEV can give place to these errors. Check the discharge temperature using the data from LGMV. In order to solve this problem, start by checking if the refrigerant is insufficient using LGMV. Through LGMV, you can also check the cycle. You can tell that the refrigerant amount is insufficient when the indoor unit EEV is fully open and the degree of superheat at the indoor unit is above 5 degrees. Superheat is a difference between the pipe-out temperature and the pipe-in temperature of the indoor unit. Also, when both low and high pressure are below the target pressure for each, or the discharge temperature of the inverter is higher than usual, you can tell there is a lack of refrigerant. Low refrigerant volume may cause excessive discharge temperature. There are two possible causes for lack of refrigerant. Maybe the right amount was not charged into the system from the very beginning, or there is a leakage in the piping. Check the brazing and flare connections of the air conditioner. To make sure there are no refrigerant leaks, check for bubbles. Also, check that the piping is not deformed. If no leakage or damage to the piping is found, you will have to inspect other factors. First, remove the front panel on the outdoor unit, and then disassemble the control box of the outdoor unit. Check that the discharge temperature sensor is in the proper location. Measure the resistance across the two lines of purple and black connectors connected to the external PCB. This error will occur if the value is greater than 5 megaohm or smaller than 2 kiloohm. If the resistance value is in range and it matches the discharge temperature, the discharge temperature sensor is normal. See the guidebook appendix for more details about resistance values. Inspect the voltage of the discharge temperature sensor. Check the discharge temperature sensor connector DC voltage on the external PCB. The normal reading is 5 volts. If you find any problem with the discharge temperature sensor, replace the broken sensor. To remove the broken sensor, unfasten the clip, remove the insulators, and pull them out. Make sure the DC voltage from the external PCB, the blue connector, is 5 volts. Finally, check the outdoor unit electronic expansion valve. When you reset PCB power, the EEV opens and closes again, and if you hold the EEV valve on your hand, you should feel it vibrating.